Welcome to Key Tech. Please describe this channel if you're interested in today's video. Dutch lithography machine manufacturer ASML surpassed Japan's lithography machine duo, Nikon and Canon, with its immersion DUV technology. Later, with its exclusive monopoly on cutting-edge EUV lithography machines, it further widened the gap, solidifying its position as the global lithography machine leader. Despite this, ASML did not stop its progress, taking it a step further than conventional EUV to create the more advanced High-NA EUV. However, ASML is now somewhat frustrated because TSMC continues to refuse its requests. From the very beginning of immersion DUV lithography, ASML and TSMC established a strong cooperative relationship. Immersion lithography technology was invented by TSMC's technical expert, Lin Benjian, and ASML then took the risk to try its application. At the same time, TSMC provided strong support, being the first to put immersion DUV into use, which allowed ASML to open up the market. With this close cooperative relationship, TSMC had priority purchasing rights when ASML launched its advanced EUV lithography machines. To date, ASML has shipped approximately 200 EUV lithography machines, with TSMC alone purchasing 107. This means TSMC is the wafer foundry with the largest number of EUV lithography machines and is currently the only semiconductor giant globally with over 100 EUV machines. Since 2019, it has purchased over 25 EUV lithography machines annually. It is precisely because TSMC possesses the largest number of advanced EUV lithography machines, more than Samsung, Intel, SK Hynix, and other wafer foundries combined, that it controls over 90% of the global production capacity for advanced chips below 5 nanometers. However, when ASML went a step further and launched a more advanced High-NA EUV, TSMC's attitude suddenly changed. Strictly speaking, EUV lithography machines have only undergone 2 generations of development. After the introduction of the new generation of EUV, the older EUV was called ordinary EUV, with a numerical aperture of 0.33, and compared to the new generation EUV, it was called low-NA EUV. The new generation of EUV is named High-NA EUV, with a numerical aperture of 0.55 mm. Its performance and functions are more advanced, and naturally, its price is also higher. A standard EUV unit costs approximately $150 million, while a High-NA EUV unit costs $400 million. Standard EUV is mainly used for 7 to 3 nanometers process chip manufacturing, while High-NA EUV is used for 2 nanometers and below chips. If wafer foundries continue to rush to purchase EUV equipment as before, then lithography machine giant ASML would be making huge profits, since a single High-NA EUV unit costs $400 million, roughly equivalent to the price of 3 standard EUV units. However, this didn't happen. and ASML probably didn't anticipate that its largest customer, TSMC, would be less enthusiastic. Intel and Samsung have both placed orders for High-NA EUV from ASML, especially Intel, whose second unit is almost fully installed and is being used for mass production of its 18A process chips. But TSMC remains silent, showing no intention of purchasing. What frustrated ASML even more was that TSMC publicly stated at a technology analysis conference in the Netherlands that its upcoming 2 nm process can be achieved using existing EUV technology, and it has no plans to adopt High-NA EUV for its 1.4 nm process. This means that it doesn't plan to use High-NA EUV for the next 2 generations in the next few years, meaning it won't purchase it before 2030. Even the 1 nm process won't use it. Further processes will depend on the situation. According to TSMC, they will continue to use the existing conventional EUV, employing a new photomask protection technology to advance the research and production of 1.4 nm and 1 nm process chips, achieving this without High-NA. While TSMC still refuses to adopt High-NA EUV, it's not a complete rejection. It simply stated that it will purchase from ASML in the future when necessary, provided the cost and value are relatively reasonable. Currently, it's too expensive. It seems that the high price of High-NA EUV is indeed a major factor. Switching to it would be very costly for TSMC. In response, some foreign media outlets have directly commented that the turning point for lithography machines has arrived. While the manufacturing process is becoming increasingly advanced, the price is also rising, to the point that wafer foundries are finding it unsustainable, let alone chip design companies, which are also nearing the point of collapse. After all, the performance of advanced process chips is already exceeding capacity, and it's time to consider whether to continue accelerating upgrades at this pace. ASML's EUV lithography machines have essentially reached their end. If they continue, they really won't be able to sell them.